Why should we even care about database backups? Let's find out. Welcome to this video on backing up SQL Server. My name is Kevin Fiesel and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. This is the beginning of a brand new series on backups in SQL Server. Before we get into some points around how we perform backups, I do want to spend a little bit of time in the classroom on the why, so join me as we make our way into those august halls. At its core, a database backup is simply another copy of our data. Every database product needs to have some mechanism to perform a backup, though the exact means by which we do it will differ from product to product. For example, some database products will dump out text files of database contents as their backups. SQL Server does things a little differently. It uses a binary format known as the Microsoft Tape format, which Microsoft used, not surprisingly, for reading and writing data to removable devices like tape drives. In SQL Server's case, we capture both data and transaction log information in the .back file that we generate during a full backup. We'll talk a bit more about types of backups in the next video, so I'll leave it at that for the moment. Instead, what I want to talk about in the classroom is a simpler question. Why do we take backups? Now, seasoned database administrators know this already, but I want to start from ground principles here as we were all new to this task at one point or another. The single biggest reason we take backups is because hardware fails. The older your machine is, the more likely it is to fail. Disks can fail, wiping out some or all of our data. And even if you're dealing with pristine hardware, lightning strikes. Sometimes literally. I have dealt with the aftermath of data centers flooding and servers catching on fire, as well as more prosaic issues like simple drive failures. This leads me to the second reason. Even before drives actually fail, you can end up with database corruption. Steve Stedman and Derek Bovenkamp have a nice video discussing some of the causes of database corruption they have experienced, including fiber optic cable failures, drives going bad, and even putting servers near train tracks. Database corruption is not a topic I'm going to spend much time on in this series, but I will say that the easiest way to fix database corruption is to have good backups to which you can revert. And by the way, I will link to that database corruption video in the show notes below. Let's talk about the third reason, user error. Any user who has the power to modify data has the power to cause a mess. That might include deleting important data, accidentally dropping the wrong table, or writing an update statement without a where clause. Every experienced DBA will be able to tell you at least one time that DBA has messed up a database. And let's be honest for a moment, if a database administrator claims never to have messed up a database, that is either someone who is brand new to the job or someone about whom you should be very suspicious. And that's just DBAs. Now, add in developers, systems administrators, end users, power users who have way more rights than they probably need. You have a recipe for possible disaster. Vaguely tied in with this third reason is my fourth, and that is bad actors. Think about processes encrypting files as part of our ransomware attack. If you have a good and immutable set of backups, you can remove the malicious software, clear out the threat vector, and restore your data to its prior state. If you do not have those backups, the best case scenario is that after paying the ransom, you get your data back. The worst case scenario is needing to rebuild from scratch and you've paid a ransom. Or even if it's not a ransomware attack, a malicious individual with too many rights may perform sabotage. This could be a disgruntled employee, an underhanded competitor, or even just someone out for the lulz. Regardless of the reason, it is a good idea for us to take backups. And in this demo, I'm going to show you some of the basics of taking backups in SQL Server. Here we are in SQL Server Management Studio. I am currently connected to a SQL Server instance, R9. This is using SQL Server on Windows, but honestly, the mechanisms are the same for SQL Server on Linux, so I'm not going to show that here because it would be the same operations happening just with a different operating system underneath and a slightly different file system structure. Let's select the plus and drill into our instance. We can see a few folders, one of which is databases. Let's drill into that and see all of the databases I have set up. Suppose I want to take a backup of the Chicago parking tickets database. By the way, I am always happy to give Daniel Hoopmacher a plug for creating this fantastic demo database, covering every parking ticket the city of Chicago wrote over a nearly 2-decade period. This is a large data source, and though I won't be able to use it exclusively in this series, I am going to use it a lot. Okay, back to the main show. There are several methods you can use to back up this database, or any other database for that matter. I am going to show you one such method today. Over the course of this series, we will see a few other techniques. Let's right-click on the Chicago Parking Tickets database. Then, from the Tasks submenu, I can select Back Up. Note that there is a corresponding Restore menu. That's also something we'll get to later on in this series. But for now, let's select Backup. This takes us to a modal dialog in SSMS. We are going to see this modal dialog a few times in this series, so let me explain some of the functionality of the dialog in this video, and then we'll talk about more in future videos. Starting at the top, we have the source, and we can see that the source is our database Chicago parking tickets. If I made a mistake in the database I wanted to back up, I could change it here, but I made no mistake. The next thing I will briefly mention is the backup type, which is full. In the next video, I will explain what that means, but just make sure if you're following along that your backup type is full. In the backup component, the only thing I can choose is database, so that's easy enough. In the next couple of videos, I will show you how we can back up files and file groups and what that means for us exactly. Further down in the destination section, I can back up to disk. If I hit the drop-down menu, I can see that there are two options that are available for me here. Backup to disk and backup to URL. We will back up to URL in a future video, as well as talking about some of the other exotic backup locations. Below this, I have a menu with 3 buttons on the side: Add, Remove, and Contents. I already have a file entry here called chicago.back, and it is in d:/SQL/backups. If I select the Contents button, that will pop up some information on the database backup that is already there. This is some basic information covering when the last backup for this file happened, when and where the backup originated, and the login that performed the backup. I'm going to close this window and return to the main modal dialog. Let's select Remove to remove that backup file from this list. Note that it does not delete the backup file that's there. It simply means I am not going to back up to that file location. Instead, I will select Add, and that will give me another modal, one with 2 options: file name or backup device. I don't have any backup devices set up, so I will have to stick with file name. We can see that my default backup location on this SQL Server instance is d:/SQL/backups. I want to make it very clear that is the D drive on the machine running SQL Server, not your local machine. You are not backing up SQL Server databases to your computer, but rather to the machine running SQL Server. If I select the ellipsis, it will show me another modal dialog and pre-navigate me to the backups folder. Looking in here, we can see quite a few database backups, including chicago.back for Chicago parking tickets. I can also scroll up and down to see other drives and folders available to me. I'll stick with the normal backups folder and create a new file called chicagoparkingtickets.back, and then select OK. I'll select OK one more time, and we can see the new file name in my list. We can also see that the Contents button is currently disabled, as there is no metadata on that file for us to read. Let's now switch to the third page, Backup Options. I will cover media options a little bit more during the next video, though as a spoiler, we are going to need to take a peek in there in a moment. But for now, we're going to the third page. On this page, we have a backup set. That name is something that will stick with the database file. We can choose whatever we'd like, though the default for a full backup is the database name, followed by a hyphen, followed by the phrase full database backup. We can also add a description for future DBAs to read. I tend not to change those, though I suppose some companies may want backup set names to have a bit more information. Backup set expiration is something that I pretty much never set. In a future video, I will talk about what it does, and you're probably never going to want to set it either unless you do a lot of work with tape drives. The option below it, however, is a good one: database compression. If I am not sure about the database compression settings, I will turn this on and choose Compress Backup from the drop-down list. Backup compression is almost free in terms of additional CPU requirements and can significantly reduce the backup size and the amount of time that it takes to make a backup. If you are using SQL Server 2008 R2 or later, you can compress backups in any edition of SQL Server. And if you're using 2008 or earlier, well, you have my condolences. The final option is something grayed out, and that is encrypting the backup. Because of a setting in how we're backing the database up, we need to create a new media set to perform encryption. Let's go ahead and do that now. To do so, I will select the media options page that we ignored, and then select back up to a new media set and erase all existing backups. We'll talk about what exactly this means in the next video. For now, however, I will return to the backup options page. At this point, I have an option to encrypt the backup, so let's check that box. The first thing we can see is our choice of algorithm. We get AES 128, 192, and 256, as well as triple DES. You should never choose triple DES. It is just not good enough anymore. I like choosing AES 256 as my default. It is a bit more computationally expensive than AES 128 or 192, but that also makes it much more computationally expensive for an attacker who happened to get a copy of your database backup, and that's worth it. Next up, we have a drop-down for certificate or asymmetric key, and there aren't any. We will need to create an appropriate certificate that we could use to perform backups before we can encrypt this. So let's select Cancel for the moment and go back to SSMS. Then I'm going to right-click on the instance and choose New Query. And now let me paste in a little bit of code. This will first create a master key using a password for encryption. You might already have a master key on your instance, but in this case I didn't. Then we will create a new certificate called Backup Certificate 2024-2025. The subject is descriptive fluff that we can use to make it easier to understand the purpose of the certificate. We can also have an expiration date for the certificate, which means that there is a practical end of life for encrypting our backups with this certificate. If you do not set an expiration date explicitly like I did, the default date is 1 year from now. But I want to be clear, you can still restore databases using this certificate after it has expired. You simply cannot back up new databases with the certificate after it expires. For that, you would need a new cert. So if you have a long retention period for backups, you can maintain the backup certificate for years after it has expired. That's also why I named the backup certificate what I did, so that when we need a new cert, we could create one for, say, 2026 and 2027, or whatever our expiration period length is. After that, we have a command to back up the certificate to a file. We are going to write out the certificate itself into a .cert file, and then write the private key to a .key file. We will also encrypt the key file with a password, meaning that if we restore this certificate on another server, we will need the private key file and the password we used to encrypt it. And you will need the certificate, key, and password combo if you ever want to restore this database to another SQL Server instance. Cool, now we have a certificate. Let's go back to Tasks and select Backup one more time. In Media Options, I will select Backup to a new media set. Then in Backup Options, I'll select Compress Backup and then Encrypt Backup. My algorithm, as you'll recall, is AES 256, and my certificate is Backup Certificate 2024-2025. Let's hit OK and let the backup begin. I have timed this off camera, and it normally takes about 15 to 20 seconds to back up the database with encryption, so that means I'm going to need to vamp for just a little bit as it chugs along. Now, I will note that the compressed backup file itself is just under 8 gigs when I'm done with it, so this is not a tiny database. I am, however, backing up to direct attached NVMe storage, so that certainly helps me with write performance versus using an older technology. Once it does complete, I'll get a modal dialog telling me that the backup of the database Chicago parking tickets completed successfully. I'll hit OK, and That will bring me back to SSMS. If I switch over to Windows Explorer, I can see that the new database backup, chicagoparkingtickets.back, is right below the old one, chicago.back. Note that the sizes are nearly the same, even with me encrypting the database. And that is the absolute basics when it comes to backups. There is, as you might imagine, a lot more to cover, such as what you can do with these backups once you've taken them, and cover it we shall. In the next video, I will talk about the 3 recovery models SQL Server has available to it, as well as the variety of backup types supporting those models. We'll have links and show notes in the description below, and until we see each other in the next video, take care.